Welcome everyone. My name is Thomas Reisinger, and I am the Director of Mechanical Design for fiber preparation products in the ANDRITZ Paper, Fiber and Recycling division. Today, I would like to introduce a brand new development in the low consistency refining sector. Here we are in the M4 production shop at our manufacturing location in Graz, also the site of the ANDRITZ Group's head office. My colleague Nick Heckfish is responsible for the assembly of LC refiners and has prepared this new model so that I can tell you all about the technological innovations, the background and the advantages of this brand new development. Behind me is not only my personal pride and joy, but also the pride and joy of the ANDRITZ development team, our new TwinFlo Prime Disc Refiner. So, let's get down to business. ANDRITZ has been involved in fiber preparation for many years now, and we have already started up more than 2,000 LC refining plants successfully all over the world. That's why we definitely wanted to stick with the basic principles of the TwinFlo refiner. By this, I mean a disc refiner with 2 refining zones, a cantilevered refiner shaft and diverse refiner plate designs in order to accommodate the different pulp properties to the best advantage. What distinguishes the TwinFlo Prime from previous refiner models? In a nutshell, concentrated performance in a very compact design. In other words, the new TwinFlo Prime enhances the energy input, improves maintenance, and increases refiner plate lifetime. How do we do this? I'll show you this directly at the new TwinFlo Prime. We can now see the TwinFlo Prime in the open position. The first impression of the machine shows right away that the overall length has been reduced significantly. The inlet and outlet pipes are in the usual places, but the process area of the machine has been optimized in terms of fluid dynamics. The bearing unit of the TwinFlo Prime has a cartridge design and enables easy maintenance in this area. In this case, the rotating unit can be changed, complete with bearings and seals, without having to lift the TwinFlo Prime or its drive unit out of the foundations. In the standard model, the TwinFlo Prime comes with a mechanical seal, and this also has a cartridge design. The rapid changing system for the refiner plates in the TwinFlo Prime is the system that is well known from previous TwinFlo refiners. In order to adjust the refiner gap of the TwinFlo Prime, one stator refining disc is adjusted, one remains in place, and the rotor refining disc with refiner plates on either side adjusts itself automatically, so as to be axially centered between the 2 stator refining discs, a principle that we already know from previous TwinFlo refiners. Nevertheless, there is a significant innovation here. It is the way in which the rotor refining disc aligns itself centrally between the 2 stator refining discs. So far, the rotor refining disc in the TwinFlo refiner was able to float freely in axial direction on the fixed refiner shaft, on a sliding hub in the machine's process area. In the TwinFlo Prime refiner, the rotor refining disc has a fixed connection to the refiner shaft, and both components move together in axial direction. Axial position compensation between the fixed drive unit and the moving refiner shaft takes place in the coupling between the 2 units. As a result, there is no longer anything to impede axial movement by the rotor refining disc. Furthermore, the port openings in the rotor refining disc have been enlarged by 70% in the TwinFlo Prime compared to previous TwinFlo models. This improves the flow to the 2 refining zones, evens out the input of refining energy to the 2 refining zones, and prevents one-sided wear on the refiner plates. No uneven wear on refiner plates. Refiner experts know this is one of the keys to longer plate lifetime. And now, how do we manage to build such a compact TwinFlo refiner? How can we ensure that the rotor refining disc, including the refiner shaft, can float freely in axial direction? 2 questions, 1 answer. A hydrodynamic, water-lubricated plain bearing. In this fascinating bearing technology, the shaft is supported on a thin film of water. By using this bearing technology, which has been known for a long time in turbine engineering, we can gain numerous benefits in the TwinFlo Prime. For example, we can reduce the overall length of the TwinFlo Prime by 30% compared to previous TwinFlo models. This increases the machine stiffness significantly. As a result, we can achieve 25% more energy input. Furthermore, the TwinFlo Prime refiner operates without oil. The sealing water that is always needed serves at the same time as working fluid for the bearing. Another innovation in the TwinFlo Prime refiner is the viscous damping unit. It reliably prevents abrupt movements by the rotor refining disc and also operates with water. I'm sure you want to know what operating results the TwinFlo Prime can achieve in practice. Since November 2019, the 20-inch TwinFlo Prime has been operating successfully in the ANDRITZ stock preparation pilot plant, and it was able to fully meet the high expectations placed on it. Now we have reached the end of our product presentation. I hope I have succeeded in providing you with a good picture of our new and innovative TwinFlo Prime. If you need further information or wish to contact me, it is my pleasure to invite you to visit our website, andritz.com/TF-Prime. Thank you.